What if I told you the biggest hidden risk in off-grid energy systems isn't losing power, bad solar input, or even battery degradation? It's fire safety in battery banks, because when it goes wrong, it doesn't fail quietly. It fails fast, hot, and in a way that can take your entire energy system with it in minutes. That's why understanding fire safety for battery banks isn't optional. It's a core part of designing any serious off-grid system, whether you're running a small cabin setup or a full-scale energy storage system. At the beginning, you need to understand what actually causes battery fires. In modern systems, fire risk is not random. It comes from a few predictable failure points: thermal runaway, electrical short circuits, overcharging, physical damage, manufacturing defects, and poor system design. Let's start with the most important concept: thermal runaway. This is the chain reaction where a battery cell overheats, which triggers more heat, which triggers chemical breakdown, which then accelerates into uncontrollable temperature rise. This is why spacing, cooling, and battery management systems are critical, because fire doesn't start as a flame. It starts as internal heat buildup. Now let's talk about electrical faults, which are one of the most common real-world causes. These happen when wiring is undersized or terminals are loose. In high-current off-grid systems, even a small resistance point can generate heat. Over time, that heat builds up until it becomes a fire risk. Another major factor is overcharging and improper charge control. Batteries are designed to operate within specific voltage ranges. When charge controllers fail, the system can push voltage beyond safe limits. This accelerates internal stress, gas buildup, and long-term instability. Now, let's look at physical damage. Batteries installed in sheds, vans, or cabins can be exposed to vibration, impact, or moisture. System design also plays a huge role. Poorly designed battery banks often fail because of insufficient spacing or lack of ventilation. This is where battery management systems, BMS, become critical. A properly functioning BMS monitors cell voltage, temperature, and cutoff conditions. If anything goes outside safe limits, the BMS is supposed to shut the system down before damage escalates. Now let's talk about enclosure design and fire containment. A good system should limit damage using fire-resistant enclosures. In larger installations, modular separation is often used so that one battery string can fail without affecting others. Many advanced systems integrate sensors that track real-time temperature changes. Catching spikes early can prevent full thermal runaway events. Not all batteries behave the same. Lithium iron phosphate, LiFePO4, is significantly more thermally stable than older lithium-ion chemistries. Meanwhile, lead-acid batteries generally have lower fire risk but introduce other hazards like gas release and acid exposure. Heat buildup combined with poor airflow is one of the fastest paths to long-term degradation and safety risk. Fire safety in battery banks is not about reacting to failure. It's about preventing the conditions that allow failure to start. Even brands like BYD focus heavily on compartmentalization, because the safest fire event is the one that never spreads. So the real goal is not just storing energy. It's building a system where failure is contained, slow, and predictable. If you want more deep breakdowns like this about solar, batteries, and off-grid living, make sure to subscribe to my channel, Off Grid Life Tech.